Hello, welcome to my channel. In this video, I'm going to show you how to develop the scattering matrix for these two-port networks, assuming that the reference impedance is 50 ohm. So to start with, we should know which port is port 1, which port is port 2. So this is port 1, okay? We assume the voltage here is V2, and sorry, this is port 2. This is the voltage here is V2, and this is V1. Now, suppose the reference impedance is 50 ohm, and very logically, we will terminate the output port with a characteristic impedance, say 50 ohm. And this is how we nullify the diffraction. But of course, we may not be able to nullify the refraction in this case. So there is no excitation in port 2.
If we want to know the love of God, we look at the crucifix. There we read, a man who is tortured, died, who is
There
seated
is
of divinity, tarnished,
no
became sin.
excitations
The Attorney General's grand jury report identified
at
multiple
port 2.
predator priests and more than 1,000 victims. It also
So
triggered waves
if there is a signal,
alleged victims to come
a wave going in, say V2 plus, and the wave coming out of port 2, V2 minus, then very logically, V2 plus is equal to 0. And let's say we are now looking at V1. V1 is equal to V1 plus, which is the voltage, which is the voltage rate going into port 1, plus V1 minus, which is the refracted wave coming out of port 1. And we know that under this situation, we should say V1 plus the refraction coefficient because of the formula. And under this situation, we know that V1 here, V1 plus here can be extracted and we up with this formula. And this one here, gamma 1 is actually S11. So we have one equation developed. We have two equations, right? Let's say this is 1 and this is 2. And according to 2, we can say V1 plus is equals to V1 S11. So let's say right, this is 2A. So we can continue with the process. Now let's we, in order to know V1 path,
I lost my faith.
we need to find out
That's
S11. S11 can be found in many other ways. One of the ways is to use the refraction coefficients formula. And in this situation, we know that the input impedance here is equals to uh, 200. Let's say right, this is 200. Right? I'm making a mistake. 200 in parallel with 25 plus 50 in parallel with 50. And if you do it very carefully, you will find out this is 25, 25 plus 25 is 50. 50 in parallel with 200. And this is 40. And now, from here, we can find out the S11 parameter because gamma 1 is equal to S11, which is equals to 40. Sorry, I should make it clearer. I should use the formula instead. So this is the formula for the refraction coefficients at port 1, and 40 is the input impedance, and minus the characteristic impedance is 50. And by my calculations, let's see, minus 1. Minus 10 divided by 90. So I got 0.1111. So S11 is equal to this amount. The next thing that I need is to find out S21 or S12. The way how we do it is to use the system S parameter system equations. So I'm going to show you how to do it. So I have I have S11 now, and the next thing that I need is to find out S. So V1 minus V2 minus, according to our understanding, is equal to S11, S22, S12, S21. So this is the way how we develop the system equation for S parameter. And according to one of the equations within this matrix system, we know V2 is equals to S21 V1 plus S22 V2 plus. But there isn't any excitation in part 2. We can safely assume that this term is 0. V2 plus should be 0. So in this case, we can say V2 minus is equal to this one. But we have already found V1. Yeah, previously we have already found it. We have found it here. Yeah, V1 is equal to this value. So let's copy this according to the formula. So this is what we got. Now, the right side of the equation has been taken care of. Sorry, the left side of the equation has already been taken care of. But how about the right side? We need V2 minus the refractive wave at port 2. And how can we find the refractive wave from port 2? And let's go back to the network. This is the network. We don't need to find the voltage at port 2. And the question is, can we use the voltage? Can we express the voltage at port 2 in terms of port 1? This is totally possible because you have the resistance here. The potential difference here is known. So from here to here, we need to find the voltage. V2 is obviously 50 in parallel with 50. And then divided by 25 plus 50 in parallel with 50. 50 in parallel with 50 is 25. And 25 and 50 in parallel, 50 in parallel with 50 is 25. So altogether, we need to multiply this with V1. So we find out this one is equal to 0.5 V1. Okay, V2 is actually equal to 0.5 V1. And now we have already known that the incident wave at port 2 is 0. There is no excitation. So we can assume, we can say V2 is equal to V2 minus the refractive wave of, in this case, the refractive wave at port 2 is, refractive wave at port 2 is actually equal to 0.5 V1. So with this in mind, we can say the left side of this equation as 0.5 V1. So with this in mind, we can cancel out V1 and at the left side and the V1 at the right side. So 0.5 is equals to S21 plus S11. And from here, we can say 0.51 plus S11 is equal to S21. And previously, we have already got S11 is equal to 0.1111, yeah? So 0.5 times 0.1111, right? Is a recursive number, S21. So from here, sorry, minus. I almost got one. Minus. So from here, I can say S21 is equal to 0.444, yeah, forever. And remember, this is the passive level. In a passive level, just like any other passive level, S12 is always equals to S21 because this is a reciprocal network. Reciprocal network has this characteristic. Sij is always equal to Sji. So we can conclude that the S21 is equal to S12, which is also equal to 0.4444. So now we found S11 already, we found S12 already, and we found S21 already. So what is left here is S22. And how can we find S22? We can take advantage of the refraction coefficient at this point. In this case, we need to find out the output impedance. We have to short circuit the source to find it. So we terminate, we have a series resistance here, 50 ohm, and then we short circuit the source. And then we are going to find the refraction coefficient. So let's try this. So we are going to redraw the circuit here. 25, 200. So this is the original level. And now we are going to draw the source. So 50 ohm. And supposedly there is a source here. But we are now looking at the output impedance. Output impedance. This is what we are looking at. And what we need to do is we short circuit this. And with this in mind, then we will find out the gamma. We will find out the gamma at this point. Now, right, so let's do it. The ZL is equal to 50 in parallel with 200 plus 25, which is in parallel with 50. And let's check the 50.
open and UN came in, and then I could
Let's see.
to another planet. It's very beautiful,
Oh,
beautiful planet,
So
much
beautiful than the
much
last one.
more than that one.
It's more beautiful every time.
So I went up and I saw the moon and I saw the sun. I
Yeah.
passed them, and I went to another planet. So I checked that one. It's very
25, 50, 200.
came in.
So I got 28.26.
All the rows. Very beautiful. I checked. It taught me if you
261.
go to the heaven level,
So
the Buddha, the level.
I should be able to
So I
find
tested. It's no shadow. I said
gamma.
it is very planet.
S22 is equal to gamma 2, which is ZL minus plus this one. So 28.261 minus 50. 28.261 plus 50. So based on our analysis, we should get minus 0.2778. So with this in mind, we have all the S parameter determined. We can conclude that the S parameter plate matrix is
To show you God's grace through the Guanyin method. You should also do the same. Okay? Thank God every day. Be grateful to God. Be thankful to all heaven.
is
To all noble beings.
minus 0.111
who help you, which you don't even know. But you also help others, which you don't even know. That's the way. To do without doing is truly the enlightened way. It's truly the way of God's children. I love you so much, and I'm very proud of you. I saw you go out do charity.
0.444,
I saw you go
0.444, and 20
organizing vegan festivals,
minus 0.2778. So this is the answer. If the S parameter is the parameter to be determined, then this is the answer. Okay, if you have any question, you can just leave your question to the comment section of this video. Thank you.
Grateful for Supreme Master Television's teamwork